At the end of the topic, you will be able to define remote sensing, discuss the history of remote sensing. Remote sensing is the collection of data about an object from a distance. Remote sensing is the most effective technology to collect the information on any part of the Earth within a short period of time without touching the ground. Geographers apply remote sensing as a tool to monitor or measure phenomena of the lithosphere, hydrosphere, atmosphere, and biosphere of the Earth. Remote sensing uses sensors to receive and record information about an object of the Earth. The sensors of the remote sensing are placed in the helicopters, planes, and satellites. The sensors measure the electromagnetic energy that is reflected back and radiated from the object on the Earth's surface to record information about the objects of the Earth. Aerial photographs were the first results of remote sensing used by cartographers. French map makers used a hot air balloon and primitive cameras to take oblique aerial photographs of the landscape in 1858. The systematic aerial images of much of the terrain in the war zone were taken using airplanes during World War I. Aerial photographs taken during World War I helped in collecting information about the position and movement of enemy troops. Systematic vertical images were taken from civilian use after the World War I. The cartographers created accurate and detailed maps of different territories, comparing the photographs taken at different angles. Photogrammetry is the process of comparing different aerial photographs and computing accurate measurements. Maps which are created using aerial photographs are called as orthophoto maps. The remote sensing technology was revolutionized with the launch of space satellites in the 1960s. Satellites have produced significantly extended view of the Earth's surface. TIROS-1, Television and Infrared Observation Satellite, was the first meteorological satellite launched by the United States of America. The second revolution of the remote sensing technology began with the launch of Earth Resource Technology Satellite (ERTS) in the 1970s. The ERTS was renamed as Landsat in 1975. The effective applications of satellites in remote sensing encouraged several other organizations to launch their own devices. In 1986, France started the space program called SPOT, Satellite pour l'observation de la Terre. The SPOT launched 5 satellites and produced more than 10 million images. In this topic, you have learned remote sensing is the collection of data about an object from a distance. Remote sensing is the most effective technology to collect information on any part of the Earth within a short period of time without touching the ground. Aerial photographs were the first results of remote sensing used by cartographers. The remote sensing technology was revolutionized with the launch of space satellites in the 1960s. TIROS-1, Television and Infrared Observation Satellite, was the first meteorological satellite launched by the United States of America. At the end of the topic, you will be able to list the components of remote sensing, explain the process involved in remote sensing, discuss the advantages of remote sensing. Through the methods for collection, processing, and interpretation of remote sensing are diverse, all the imaging systems have basic components. There are 4 basic components of remote sensing, namely target, energy resource, transmission path, and sensor. Let's understand each one in detail. The object or material to be imagined is called target. The components work together to measure and record information about the target without having physical touch with the object. The energy source provides electromagnetic energy to the target. The energy resources are classified into 2. Passive systems such as sun and irradiance from the Earth. Active system, which is artificially generated energy resources like radar, a wide electromagnetic spectrum ranging from short wave gamma ray to very long wave radio wave used in the remote sensing. The target's interaction with the electromagnetic radiation is subjected to the properties of the target and radiation. The electromagnetic radiation transmits information from the target to sensor. The device that detects the electromagnetic radiation is called a sensor. Based on the energy received, sensor can be classified into passive sensors which detect the natural radiation emitted by the target. For example, cameras used to take daylight pictures. Active sensors transmit signal of their own and measure the energy reflected back from the target. For example, radar. There are various processes involved in remote sensing. It starts with the sun as the energy source is first requirement for remote sensing. It provides electromagnetic radiation to the target of things, sun rays and atmosphere. When energy travels from its source to the target, it will come in contact with and interact with the atmosphere through which it passes. This interaction may happen second time when the energy travels from the target to the sensor, sun rays and objects of the Earth. Energy interacts with the target based on the properties of both target and radiation. Recording of energy by the sensor. The sensor collects and records the electromagnetic radiation that had emitted from the target. Transmission, reception, and processing. Sensor records the energy which is transmitted in electronic form to a receiving and processing station where data are processed into an image. Interpretation and analysis. The processed image is interpreted visually or digitally or electronically to extract information about the target. Application. Applying the extracted information for the better understanding and to reveal some new information or assist in solving a particular problem. Remote sensing provides a synoptic view of wide area in a single frame. It detects the features of inaccessible areas. It provides cheaper and rapid method of obtaining up-to-date and continuous information over large geographical area. The planners use remote sensing to formulate policies and programs to gain the holistic functioning of the environment. It enables the cartographers to make thematic maps. In this topic you have learned, there are 4 basic components of remote sensing, namely target, energy source, transmission path and sensor. The electromagnetic radiation transmits information from the target to sensor. The device that detects the electromagnetic radiation is called a sensor. Based on the energy received, sensor can be classified into passive sensors and active sensors. There are various processes involved in remote sensing. Remote sensing systems are useful in many ways. At the end of the topic, you will be able to list the components of GIS, understand the application of GIS, explain the Global Positioning System GPS, discuss the basic concepts of GPS, describe the application of GPS. A system designed to capture, store, manipulate, analyze, manage, and present all types of geographical data is called Geographical Information System, GIS. The components of GIS include an input system that uses and analyzes the collected data for some purposes, computer hardware and software systems that store the data for management and analysis, and the data could be used to display products of data manipulation on a computer monitor, an output system that creates hard copy of maps, images, and the types of output. People of various fields use GIS. Exploration and mining companies use GIS to identify prospective areas for exploration and mining. Electricity on load on the grid network for a particular area can be monitored and analyzed by GIS. Transport companies use GIS to locate the shortest route for delivering goods. GIS is used by law enforcement agencies to map, visualize, and analyze crime incident patterns. Ecologists use GIS to understand relationship between species and distribution and habitats. A space-based satellite navigation system that provides location and the time information in all weather conditions is called Global Positioning System. The creative head of GPS is the US Department of Defense. It was established in 1973. GPS has 3 parts, namely the space segment, the control segment, and the user segment. The space segment consists of 24 to 32 satellites in medium Earth orbit and the booster needed to launch the satellites into the orbit. The control segment has a master and control station, an alternate master control station, and a host of dedicated and shared ground antennas and monitor stations. The user segments consist of the US and allied military users of the secure GPS precise positioning service and millions of civil, commercial, and scientific users of the standard positioning service. The GPS receiver estimates its position by exactly timing the signal sent by GPS satellite high above the Earth. Each satellite continuously transmits messages that include the time when the message was transmitted and precise orbital information. To avoid large positional error caused by a small clock error multiplied by every large speed of light, the receivers use 4 or more satellites to solve their location and time. GPS is a dual-use technology applied both in military and civilian sectors. Civilians' use of GPS includes surveying, map-making, navigation, cellular telephone, and geofencing. Military use of GPS includes navigation, target tracking, missile and projectile guidance, and reconnaissance. GPS is a useful tool for commerce, scientific uses, and tracking and surveillance. GPS is also used in banking, mobile phone operation, and control of power grids. In this topic, you have learned a system designed to capture, store, manipulate, analyze, manage, and present all types of geographical data is called Geographical Information System, GIS. The components of GIS include an input system, computer hardware and software system, and an output system. A space-based satellite navigation system that provides location and time information in all weather conditions is called Global Positioning System. GPS has 3 parts, namely the space segment, the control segment, and the user segment. GPS is a dual-use technology applied both in military and civilian sectors.